Hey guys, my name is Luke Thomas. I'm one of the TAs this quarter, and I will be leading you through the lecture for week 3 over the appendicular skeleton and the body's articulations. Let's start with the appendicular skeleton. What is it? Last week, you learned about the axial skeleton, which included the skull, spine, and rib cage. The appendicular skeleton is everything else, and there's 4 main categories: the pectoral girdles, upper limbs, pelvic girdle, and lower limbs. These are all highlighted in red on this image. Let's start with the pectoral girdle, in which there are 2 main bones, the clavicle and scapula. The clavicle has a sternal end, which is medial and attaches to the sternum, and an acromial end, which is lateral and attaches the acromion of the scapula. There are also some markings on the clavicle, such as the conoid tubercle and costal tuberosity. The tubercle is marked here. You can see the tuberosity, but it's not marked. It is marked on the image in your book. The clavicle is the only bony connection between the pectoral girdle and the axial skeleton, which grants it a great range of movement. You can also feel it pretty easily below your neck. The scapula is that big triangular wedge that's on your back. The actual wedge is called the body, and then there are 2 processes that come out of it: the acromion and the coracoid process. The acromion is a projection which connects to the clavicle, and the coracoid is slightly inferior to this. The glenoid cavity is an indentation where the humerus sits, and you can see that very well on the lateral edge view. Let's get into the upper limb now, and there's 4 main sections here: the humerus, radius, ulna, and bones of the hand. The humerus is the largest bone in the upper limb. You'll have to know many of the details of this bone, but for now I'm just going to go over a few important parts. This would include the head, which articulates with the glenoid cavity of the scapula, the greater and lesser tubercles, which are near the head, and the best way to distinguish these is that the greater tubercle is higher than the lesser tubercle. Then you have the capitulum, which is the articulation with the radius, and the trochlea, which is the articulation with the ulna. In anatomical position, the radius is on the lateral side and the ulna will be medial. Interestingly, this means that most of the times, such as while typing on a computer, the radius is actually sitting on top of the ulna. Again, there will be several tuberosities, processes, and notches you have to learn on these bones, but I'm not going to go over all of those. I will mention the olecranon process, which latches into the olecranon fossa of the humerus to create a hinge joint there. Also, note that there is an interosseous membrane between the 2 bones that isn't shown in this picture. Finally, on to the bones of the hand. There are many bones in the hand, but in general, there are just 3 divisions. You have carpal bones, which are the wrist in blue, metacarpals, which are the palm region in yellow, and phalanges, which are red in your fingers. Phalanges can be further divided into proximal, middle, and distal phalanges. That's pretty much all you're going to have to know for bones of the hands, and that finishes upper limb. So now we can move on to the pelvic girdle. The pelvic girdle is made up of coxal bones, the ilium, ischium, and pubis. In reality, after puberty, they all form a single bone and simply represent sections, which can make it hard to distinguish between them. But we're going to look a little bit closer now. So some of the parts of the pelvic girdle include the acetabulum, which is the notch that holds the head of the femur, the obturator foramen, which is the hole between the ischium and pubis that allows blood vessels and nerves to go to the lower limbs, and then the pubic symphysis, which you can't really see in this image, but it's a small cartilaginous joint between the 2 pubises. Finally, onto the lower limb. The main structures here are the femur, patella, tibia, fibula, and tarsal bones. And we're going to quickly go through each of these. The femur is the largest bone in the body, and the superior portion is very similar to the humerus. It has a large socket, which is the head, and then greater and lesser trochanters, which is similar to the greater and lesser tubercles. On the bottom, you have lateral and medial epicondyles, which articulate with the tibia, and the patella will rest at this intersection. The tibia is the larger bone and articulates with both the femur and the foot, while the fibula is smaller and it articulates with the side of the tibia and the foot. The foot articulations occur via the talus bone and the lateral medial malleoluses. So finally, the foot. These bones are called tarsal bones, and the talus is the one that actually connects to the tibia and fibula. The calcaneus is the heel bone. Then you have cuneiform, metatarsals, and phalanges. These are basically equivalent to the three divisions in the hand, but differently shaped. So that's it for the appendicular skeleton, and now let's talk about the body's articulations. Some basic terminology. Arthrology is the study of the structure and function of joints, and a joint or articulation is any location where two or more bones meet. And there's a few different definitions of joint. You can get synarthrosis joints, which cannot be moved, and this would be a suture of the skull. Amphiarthrosis joints, which have very minimal movement allowed. An example of this would be the intervertebral discs, and then diarthrosis joints, which allow motion and would be the majority of the appendicular skeleton. So for example, the elbow. So all diarthrotic joints are also known as synovial joints, and this means that they have a joint cavity lined by a membrane. They're freely movable, and you can have varying axes of motion. It can be singular, you can have two axes, three, or multi-axial. The diagram here outlines all the key components of a synovial joint, and there's also a great one in your book that I would highly recommend checking out. There are 6 main types of synovial joints. Gliding, which is non-axial movement, such as the bones in your sternum. Hinge, which is monaxial, such as elbows. Pivot, which is monaxial and allows rotation, such as shaking of the head. Condylar/ellipsoid, which is where you have a concave to convex spooning of articulations, such as in the forearm. Saddle joints, which are biaxial, and you can only find one in the human body between the thumb metacarpus and the trapezium of the wrist. And finally, ball and socket joints, where you have a spherical head of one bone that enters another, such as the femur. The final thing you'll have to go over are skeletal movements. These are all pretty basic, and the book has great explanations, so I'm just going to give quick picture examples for a few of these. Also, take note that the APR code is on this slide, and hopefully it'll work right off the bat this week. So this is a picture showing flexion versus extension. I like to think of bicep curls to help with this, flexing and then extending as you release. This one shows hyperextension, which is simply extending further beyond what is normal for your body. Then you have abduction and adduction. These are pretty easy to get mixed up. Abduction is moving your hands away. Adduction is moving towards the midline. Then you have circumduction, which is a rotational movement. Supination versus pronation. And my final example will be eversion versus inversion. So that's the end of my lecture. Hopefully all this is making sense to you guys, and good luck on all of your assignments.